Okay, this will be a short video. I'm calling it the Andy Griffith math problem. It's just basically a problem involving compound interest, but it's a problem that appeared in one of the episodes of the Andy Griffith Show. The first episode aired in 1960, and it went about 8 or 9 seasons. It was one of my favorite programs growing up. And so we're going to look at this problem. I've done similar problems on this channel and also on my other channel, but here it is. Let me give you a little summary of the episode that I'm talking about. In this episode, Andy is asked by the town council to evict a man by the name of Frank because he's behind in his taxes, his house is run down, and the town people want him out of the house. Andy is hesitant at first, but he visits him and he's trying to help him out, and he wants to find out if he has anything of value that he can sell so he can pay the taxes that he's behind in. And what Andy finds that he has is a bond that was issued by the city of Mayberry back in 1861. So at first, you see the value of the bond is $100. You think, okay, well, they get $100 and a little bit of interest. But then Andy notices that it's for 100 years. So 1861, and now it's 1961 in that particular episode. So Andy goes to the bank to calculate the interest, and he's surprised. So here's the formula. If you want to do it manually, the amount or future value is the principal multiplied by, in parentheses, 1 plus r over n, where n is the number of periods. So in other words, if it's compounded annually, n is 1. If it's compounded semi-annually, n is 2. Compounded quarterly, n is 4. Monthly, n is 12, and so on. And t is the number of years. So if we take the $100, which would be P in this case, and plug it into this formula, it will look something like this. P is 100, interest rate is 0.085, converted to a decimal, and then N is 1, so that becomes just 0.085, and then N times 100, N is 1, so that'd be 1 times 100 is 100, and if you do that calculation, it comes out to $349,119.27. And the problem is the town cannot pay that amount of money. So they're trying to find ways so that it doesn't cash the bond. So they help him fix up the house, they paint it and so forth, and he's allowed to live there. And then they find out at the end that because the bond was bought during the Confederacy Civil War, it couldn't be paid, and Mayberry was part of the Confederacy. It couldn't be paid with Confederate money, which meant it was worthless. But either way, it turns out okay. The old man gets to stay in his house, but he doesn't get the $349,119.27. Now, if you want to calculate it, compute this out in a graphing calculator. It'll look something like this. So it'd be 100. Using the formula, parentheses, and then 1 plus 0.085, parentheses, and then taken to the 100th power. Oops. Okay, and hit enter, and we get 349,119.27. And of course you can compute this out in using a scientific calculator. This particular calculator, the TI-84, also has an app here. So if I hit the app here, as the finance menu, hit enter, and the first one is 1, and that's the one I'm going to use. The TVM solver allows you to solve finance problems. So n in this particular case is the number of periods. So because it's 100 years and it's compounded annually, it's 1 period per year, so n in this case would be 100. So I type in 100 here. And then the interest rate is 8.5, and it's entered in that way. We don't move the decimal over like it did for the formula there. This is set up different. 8.5. And then the present value is in this case represents the principal, which is 100. Payment we'll leave at 0. And then we want to compute actually the future value. So if I deposit the $100, what do I have after 100 years? So the other two stay, periods per year would be 1. They'll stay 1. And so in this case, I just put it on the FV for future value there. And then I want to solve it, so I hit the green key, alpha, and then enter. Hit solve, so it's alpha solve, so alpha, and then enter. And I get 349,119 rounded off to 0.27. And you can ignore the negative sign here. Okay. And I could have fixed that by just putting a negative 100 here. Okay. But just ignore the negative, and it comes out to 349,119.27. Okay, so that's the solution, and then this is just to remind you again that it pays to invest and have a little patience. So obviously you don't want to wait 100 years to cash in your bond, but you get the idea as to what can happen if you deposit a certain amount and let it sit there for a good period, say for retirement and so forth. Okay, hope you liked the video, and we'll check you next time. We'll have some more videos coming up on some sets and some other things. So as usual, if you have any suggestions or any videos that you want to see, types of problems, please post them. And if you're subscribing to the channel, I'll be more than happy to listen to your request. Thanks for watching. We'll see you next time.